Okay, so let's look at some theorems about parallelograms. I've got a diagram there for you. Let's talk about what's marked so far. We talked about the little tick marks with the triangles, meaning that those pieces are congruent. So we'll get to that here in a second. What do the arrows mean? Parallel lines, okay? I think y'all already know that the definition of a parallelogram is that it has two sets of opposite sides, right? So AB is parallel to DC, and AD is parallel to BC. Well, it turns out that not only are those sides parallel to one another, if it's a parallelogram, they are also congruent to one another. Okay, so that is property number one that you need to write somewhere on your paper. Opposite sides are congruent. Opposite sides are congruent. So in this specific case, that means AB is congruent to CD or DC, however you want to phrase that there. Okay, and AD is congruent to BC. If you didn't know the congruent symbol before, it's the equal sign with a little squiggle over it. Okay, that means they're congruent. That means they're equal to each other. All right. So let's mark that. In addition to the parallel lines, let's mark this one with 3. Okay, AB congruent to CD, and then AD congruent to BC. You have to add that many tick marks to it, because if we went back and used just a single tick mark, that would also be saying that it's the same length as BE, okay, and it's not. So you got to be careful with that. Okay, so we've got opposite sides are congruent. Let's talk about the angles. Okay, Well, while we're talking about sides, let's talk about those diagonals. Okay, let's talk about those diagonals. A to C is a diagonal. Okay, B to D is what we call a diagonal. It connects the opposite vertices of our parallelogram. So with the way it's marked, those diagonals bisect each other. Okay, property number 2, diagonals bisect each other. Now they're not equal to each other. AC is not the same length as BD. That's pretty obvious on the diagram there. But AE is congruent to EC, and DE is congruent to EB. Okay, they cut each other in half, but BD is longer than AC. Okay, now let's talk about the angles. Okay, let's talk about our angles here. In your parallelogram, opposite angles are congruent. So the angle at A is congruent to the angle at C. The angle at B is congruent to the angle at D. Okay, angle A is congruent to angle C. Angle B is equal to angle D. So opposite angles and let me show you a little bit of a different notation. Okay, you can write angle A is congruent to angle C, or you can write M with the angle B. That represents the measure of angle B is equal to the measure of angle D. Okay, angles are congruent to each other, measures are equal. Okay, that's just a little technicality, but I wanted to show you that notation. Okay. Now, we can also talk about adjacent angles. What are adjacent angles? They're beside each other. Okay, opposite angles don't touch at all. Adjacent angles are beside each other. So adjacent, beside each other. Adjacent angles are supplementary. What does it mean to be supplementary? They add to 180 degrees. They add to 180 degrees. So, the measure of angle A plus the measure of angle B equals 180 degrees. The measure of angle A plus the measure of angle D equals 180 degrees. And B plus C equals 180, and C plus D. So what's the total for our angles in a parallelogram? What's the total measure for all the angles in a parallelogram? 360. If adjacent ones added together are supplementary, they add together to give you 180, then this side plus that side must equal 360. Or another way, all angles sum to 360 degrees. Okay. Another way to remember it, think about a square. Okay. A square is a quadrilateral. A square is a parallelogram, actually. It has two pairs of opposite parallel sides. What are all the angles in a square? 90. And you got 4 of them. So total is 360. Okay. So this kind of parallelogram is just like a square pushed over. Okay, you're just adjusting those angles. So it's always, they sum up to 360 degrees. Now, what figure do I have below this one on your paper? A rectangle. Okay. A rectangle is a special case of a parallelogram. So all of these properties that we've just covered apply to a rectangle. Plus, there's one more specific property. Can anybody just maybe see something that's a little more specific about this rectangle compared to just the general parallelogram? Okay. There is a point there that does look like it's directly in the middle of it.
Triangles.
Okay.
Midpoint.
Okay.
90 degrees.
Okay. The angles are 90 degrees. That is another more specific thing about it. How about with the diagonals? What's the difference between these diagonals and the diagonals of the parallelogram?
They are all equal.
These diagonals are equal to each other. Okay? The diagonals of the parallelogram were not equal to each other. One was longer than the other one. But this one, they are equal to each other. So this is a property we need to know. If the diagonals of a parallelogram are equal, or congruent, then it is a rectangle. Okay, if the diagonals of a parallelogram are congruent, then it is a rectangle. Now, a square also matches that description. Did y'all know that a square is a rectangle? Okay. But not all rectangles are squares. Okay. All squares are considered rectangles, but not all rectangles are squares. Okay, it's kind of like, I don't know. Think about kind of a chain of events. You got parallelograms up here, okay, and then you get more specific. One more specific detail, you got a rectangle. One more specific detail, you got a square. Yes, sir.
In third grade, like you could study PQRS, and it's like it goes in that order, one way to the other.
Okay, that's good. Yep. I guess Q is that quadrilateral.
Yep.
The Q should come before the P, but anyways.
Maybe I remember it wrong.
It's okay. It's all good. But that is a good point, though. You can only go in that order. You can't go the other way. But quadrilaterals are more general than a parallelogram. But anyways, all right. So here's what we're going to do with this. I've got a worksheet here.